Hello, welcome to Part B of the Quantitative Analysis Unit. You need to do Part A, the titration practical, and this Part B before you get the credits for this unit. Part B is all about something called stoichiometry, which is a chemistry word which comes from the Greek stoichion, which means element, and metron, which means measure. So it's all about measuring elements, and when in chemistry that often is all about finding the amounts of substances that are involved in reactions. Here is a summary mind map of what needs to be done in Part B. There are 3 parts as indicated in yellow. The first part here is the percent composition, and that's what we'll be covering in this lesson. The second part is using the percent composition and a molar mass of a compound, working out what its empirical or simplest formula is, and then by using the molar mass working out what its molecular formula is. Thirdly, we need to work out, using the mole ratio in an equation, how much of a substance would be produced or reacted. Given a known mass of a reactant or product, working out the unknown mass of a reactant or product. So those are the 3 things that you'll be given in this assessment for Part B, which is a completely written assessment. There is no practical aspect of it. So firstly, we're working on calculating the percent composition in a compound. So a couple of compounds, for example, are water and carbon dioxide. In order to work out the percent composition of elements in these compounds, firstly you want to know the molar mass of the whole compound. So we've done this before. The molar mass of H2O would involve looking at the mass number from the periodic table of hydrogen, which is 1, and because there's 2 hydrogens in the formula, I need to multiply that by 2. Then add the molar mass of 1 oxygen, so that equals 18. The molar mass of carbon dioxide, carbon's got a molar mass of 12, and oxygen is a molar mass of 16 times 2. It's important when you're entering this into your calculator that when you're adding something and then timesing something, that you put the timesing in brackets. That total is 44. Remember, the units for molar mass is grams per mole, which can be written like this. So this is the total mass of the whole compound. In a percent composition calculation, you're giving what percent of the total mass is made up of the elements which are in that compound. For example, what percent of oxygen is there in that water or the carbon dioxide? So here is the calculation that you're going to need. We find out what is the mass of the element that we're looking for, which is oxygen, and what's the total mass of the compound, which is that big M we've just worked out up above. Okay, so for the percent oxygen in water, we find that oxygen's molar mass is 16, so that's the mass of the element as indicated in red. We need to percentage, so we're going to times that by 100. And the total mass, as we worked out up in blue, was 18. So if we throw that into our calculator, we get 88.9%. So in any amount of water, 88.9% of it is oxygen. Okay, so second example, we want the percent oxygen in carbon dioxide. So again, we want the mass of the element, which is our 16. But because carbon dioxide has 2 oxygens in it, we need that 16 times by 2. And then we want to multiply our answer by 100. And then the molar mass, as we worked out up here, was 44 for carbon dioxide. So we throw that in our calculator and we find out that in carbon dioxide we've got 72.7% oxygen. So in your workbooks you've got some common questions that we get on percent composition calculations. So now you know how to do it, you can go ahead and do those. Good luck.